right, thank you, Dan. And I didn't hear if there was a title of a research project or whatever, but any research that INDOT does with Purdue is on programs called JTRP, which is Joint Transportation Research Program. You can Google that and find it, and you can search for research reports that are on the website. So based on that one, it sounds like it might be there. All right, our next presentation is about the Contractor Quality Control Plan, document that lays out a lot of the rest of the things I guess we're going to talk about today. We've got Jay Winker back, and then also Brad Curry from Milestone Construction.
Yeah, we're going to, like Matt said, we're going to talk about a quality control plan, what it goes into it. Typically what we've done in the past is gone through all the things that go into the quality control plan as a process or as the class goes on, and we do this at the end. So kind of doing it beforehand, give you ideas that go into the plan. We'll show a example of a quality control plan, and then we'll discuss later on the get into details of the milling and paving operations, things like that. Get this figured out, I'll be all right. There we go. So I say we'll spend about 45 minutes just going over what goes into the plan. I always put in minimum requirements of the plan because you can get really detailed. I think our plans are like 26 pages long already. So the one thing about most of it on the quality control procedures is it's ITM 803, and ITM 803 not only talks about HMA quality control plans, but goes into other operations like concrete paving and I think maybe soils, dirt work, whatever. But we'll talk about HMA. I always like to say, put into the quality control plan, say what you're going to do and do it. Pretty simple. So the first item in the quality control plan is just discussing the contractor personnel. So contractor personnel, the three people that need to be identified in the plan are the QCP manager. This would be like the overall person that's involved with the company for the project. The QCP site or the field manager, which is the purpose of this class is to get a field supervisor. Sometimes in your plans, this could be the same person, whether it's a field person or the QCP manager. And then your quality control technicians. In this case, I look at the quality control technicians as everybody on the paving crew. So it's not just the quality control department. So it's everybody that's involved with paving operations is a quality control technician. Item 2, milling. Milling operation. Scott and Brian will talk about this later on, but identifying what the milling plan is, identifying the equipment that you're going to use for the milling plan, and then the testing that goes into checking to make sure the mill is in good shape, and that's at ITM 812. And then we'll go into the process balance, which Jay's going to talk about, but this is mainly just talking about the just the balancing from plant production to having the proper rollers, proper compaction for the project, and then making sure you got the proper amount of trucks for that project. So we've got a couple problems I think we're going to go through. Jay?
Like Brad said, in your QC plan, you have to talked about the process balance and how you were going to calculate or how are you going to figure out to keep everything in balance, you know, as far as plant production, transportation, how many trucks do you need, your paver speed, and then how many rollers do you need to accomplish your goal for the day. And what you guys have, front page, this scenario for all three problems, we're trying to get down 900 tons in 6 hours. Truck cycle time, round time is 89 minutes. We're gonna say the average truck size is 20 tons. We're paving 12-foot wide, doing 1.5 inches, and using a 66-inch wide roller. So if you go to the first problem, we're gonna determine how many trucks you actually need. The given information has been filled in. If you guys want to go ahead and work through this, we'll give you a few minutes and then we'll go through it together. Yeah. Okay, I can walk them through it. We'll go through it here pretty quick. You're given the 900 tons, 6 hours. So your rate of mix needed to be delivered to the job sites, 900 divided by 6, 150 tons per hour. Your plant is rated at 300 tons per hour, so you're good with plant capacity. Average truckload's 20, so 900 tons divided by 20, you need 45 loads or 45 trips. Your total cycle time, the 89 minutes, convert that into hours, 1.48 hours per trip. The number of trips per truck, the number of trips that one truck will make within that 6 hours, your 6 hours divided by 1.48, each truck can make 4 rounds. You know you need 45 loads total, and if each one can make 4 rounds, you take 45 divided by 4, you need 11.25 trucks. You got to round up to 12 trucks. And just double check yourself. Your 12 trucks times 4, that'll get you 48 loads in 6 hours, which is greater than your 45 required. Now your next one that you're going to work through is the paver speed. You know, what speed are you going to run your paver at to be consistent all day long in those 6 hours? So that's the second problem you guys have, so go ahead and work through there. What I came up with was 23 divided by 0.8, so 29 feet per minute. We'll walk through it here. Once again, 900 tons, 6 hours, once you're 150 tons per hour. Your paving width of 12 foot, thickness of 1.5. Convert your 1.5 inches to feet, divide by 12.13 feet. Specification limits for density, it says 92, but it should be 93. Target, what we're shooting for is 94. And based on your mix design, your density, your reference density is 146. We're looking for 94% of that, so 137.2. So actual paver, well, first off, let me back up. To convert conversion factor from tons to pounds and hours to minutes, it's 33.33. So we've got 150 tons per hour is your mix rate, times 33.33. Divided by your width of 12 feet, divided by your depth of 0.13 feet, and divided by your density of 137.2. So if you do that math, your paver rate is 23 feet per minute, but your paving efficiency factor, we're going to say 80%. You know, yet that paver isn't moving that speed all day, every day, so we're going to say it's going to run on about 80% of that. So you take your 23 feet per minute and divide it by 0.80, give you your 29 feet per minute. Does that make sense? The final one we'll look at is your compaction production calculator or calculation form. And that will tell us number of roller passes, number of rollers, and the roller speed. So if you want to go ahead and work through that, we'll give you about 5 minutes. All right, we'll keep moving on here. It was brought to my attention that on the last problem, there was a mistake on the bottom. It should be your paver speed, 23 feet per minute times 0.8, which would reduce it down to 18.4 instead of divide. So, sorry about that. Now we'll go through the compaction, which the actual speed of the vibratory rollers can be based on the roller's operating frequency. So that's all based on each specific roller. But we're going to work through here, given the information on this sheet, the actual speed or your vibrations per minute is 2520 divided by 10 impacts per feet. So you can go 252 feet per minute. And to convert that into miles per hour divided by 88, 2.9 miles per hour. Your effective speed is that 2.9 miles per hour minus 10%. So if you work through the math, you got your 252 feet per minute, deduct 10% from that, you're down to 227 feet per minute divided by 88, get your 2.6 miles per hour. Your drum width is 66, that's given, and then you need to deduct, to allow for 6-inch overlap with each pass of the roller, you need to deduct 6 inches off of that. So in essence, you really have a 60-inch wide roller. Paving width is 12 foot, so now we'll calculate the number of passes to cover the mat with one time. So you got your pass, 12 foot, divided by your 5 foot, which is your 60 inches divided by 12, your 5 foot. You end up getting 2.4. Well, you got to round up to the whole number, so you have 3 passes. Number of repeat coverages to achieve density. This is based on your test strip. You got to go over it twice. So that means you got 3 passes 2 times, so actually you have 6 passes. Well, in order to get yourself back up to the paver, if it's an even number, you have to add 1. So just think about going back and forth. If you have an even number, you're going to end up back where you started. You need to add another 1 to get back up to the paver to continue on. Roller efficiency, we're going to say once again 80%. So effective compaction production rate, your C rate is what they call it, is your effective speed. So your 227, which you calculated up top, the effective speed up top there, your 227 feet per minute, times your 80%, divided by 7 passes is equal to 26 feet per minute. So you compare your plant rate is 300, so you're good there. Tons per hour. Your delivery to the job is 150 tons per hour, so you're not overloading the plant. Your paver rate is 18. Well, the revised number is 18.4 feet per minute, and your compaction is you can go 26 feet per minute. So that means that 1 roller can keep up with the paver. Now, if the paver speed outpaced your roller, then you'd have to add another roller to it. So, I know we went through that pretty quick. Does it make sense? All right. So, you did your process balance. Now you've also got to talk about the transportation of the mix, to the job. Truck bed covers. When are you going to use them? Who's going to determine when you use them? You know, you got to spell that out. Is there a certain temperature that you're going to start tarping over the sides? You know, you can spell all that out in the quality control plan. Unloading, your procedures for unloading the mix and removing the excess material from the apron. So spell out, you know, is the truck going to stop shy of the paver to avoid the bump? You know, like Brad said, basically spell out what you're going to do. So INDOT, everybody knows, everybody's on the same page ahead of time, so you don't have issues once you get there. Your transfer vehicles, you know, you got to spell out, you know, in ours, I think we say we reduce it to 50% capacity before we cross the bridge. So those are just items that you should include in there. Paving, you need to list your equipment that you're going to be using with your make, model, serial numbers. Your paving plan and general sequence, you know, what are you going to do first? What lift are you going to do first? How many lifts are you going to put your 8 inches of base in? You're going to spell it out that you're going in 2 lifts. You'll place that. Material feed system. You know, what are you going to do? You know, are you going to have the folders or the hoppers folded, or are you going to use a hopper? Your grade and slope. You know, what are you using to control your grade and slope? And you're going to talk about your joints and the asphalt material that's going to be used. And when you talk about the, sorry here, let me get caught up. You know, talk about your longitudinal and your transverse joints. You know, how are you going to take off from a cold joint in the morning? You know, you're going to set up on a piece of lath, you know, basically, you know, to allow for compaction. You know, how are you going to overlap your joints, or, you know, when you're paving and compacting them? Transverse joints, you know, are you going to cross roll them? You can spell that out in there. You know, if you have the room, you can try to cross roll it. I think that's on to you.
All right, 4 more items, and that need to be put in the QC plan. The next thing, item 7, is the all your material testing. So remember, it's a QC plan, so it's just items that the contractor is going to do to control different processes in the operation. So 5 things on the sampling is you have to address mixture properties. Typically, we put in there in our plans that we're going to control the mix at the plant according to another QC tool is the ITM 583, which is a certified asphalt plant for INDOT. So we do all of our testing there at the plant according to that. Mixture, the temperatures at the paver, we got to designate how often, who's doing the temperature at the paver. We got to address the density, how we're controlling density, whether we're using a nuclear gauge or a non-nuclear gauge or cores or whatever it might be. Had a paver guy or one of our density guys that used a heel of his foot. As long as his heel of his foot was good. Anyway, coring, so how you're going to do your coring, and then address your smoothness. Item 8's response to all these test results. So if you get a test result that's out of specification or needs to be addressed, it's just you gotta put something in your plan to address the items that are out of specifications or just need addressed. So whether it's you know, cold feeds or plant mix or roller operations that Jay talked about. So paving smoothness, how you're going to address your smoothness now coming into play and needs to be addressed is the IRI now. So we're getting away from the profilographs and So RI is going to have to be put in these plans here in the very near future. And 10 is documentation. So just going through these bullet points. QC test results, documentations of equipment needs to be maintained for a minimum of 3 years. So just find some place where you can store these QC plans, whether it's on a plant drive, a master drive, or a hard copy in some file cabinet back in the basement or somewhere. You just got to keep the records on file for 3 years, according to ITM 803. Accessible to INDOT anytime, so they have the right to come in anytime to look at your QC plan. Minimum test results for mixture, temperature, density, smoothness test. So these are all test results you keep on file as well for 3 years. Documentations of manufacturer, model, type of paver, rollers used in everyday paving. One thing I like to do on the plan is just put in all the equipment that could be possible to go in this project. So once something breaks down and you need to use another piece of equipment, then you've got to get the addendums made to your QC plan and get those approved by the PE before you can proceed in paving. Any modifications is equipment, so like the segregation kits and everything else are out there. So those have to all be modified or documented. So just item 11 is just your actual QC plan, which I'll go over a plan. I'll go over it quickly because I know it's getting close to break time. The QC approval, make sure you get the plan done. The QC approval is supposed to be submitted 15 days prior to you start your paving operations. Sign the date when it's submitted to the PE. You'll have an authentication page to be countersigned by the PE. You're not supposed to start your HMA operations until it has been approved. So I always say, just if you put everything in your plan that's in specification, there's no reason it shouldn't be approved. With that, I did like it. I think today's date's pretty cool, 02/22/2022. Jamie, can you, there was a Word document for the QC plan. So this is just describes the project, the INDOT project number, where it's located at, and the location of the job, just kind of the cover sheet. Okay. And the first thing is listing the, as you follow along with the PowerPoint, you'll have your contractor personnel, so you need to identify the QCP manager. What I like to do is also put a backup for the QCP manager, so I'll list whoever the main person is, backup is, in case that person is unavailable to show up for a job or is on vacation or something like that. So. I was about ready to get to that, Bill. I'll address that here in just a couple slides. Go ahead, Jamie. QCP field manager, that's, I say, the person that's taking this class. Again, the main person, and then the backup for it. Go ahead. And this is where I was going, Bill. So these quality control technicians, I always list everybody that's involved on the paving crew into these jobs. And like Bill pointed out, most of these people, I think, are going to be fired based on their performance last night for the last 2 weeks. I've been very pleasing. All right, go on. I don't even want to look at those names. Milling, the second part of the QC plan is just addressing the milling. So talk about the testing, any of the milling operations. Say Brian and Scott will talk about this later on this afternoon. So, and then 3 is the process balance. So just like Jay went over with your plant production, your paver production, and then your compaction calculation. Number 4 is transportation and mixture. So the main thing in here is just talking about if you're covering your mix, to make sure it's all covered from the weather, from all the elements. I also get addressing the unloading of the trucks, and if you use an MTD for paving. The main thing under the transfer vehicles, talking about you have to have a plan for how you're going to cross bridge approaches and everything. That's part of ITM 803. Number 5 is your paving operation. So this is just listing your the types and serial numbers, models of all your paving equipment. What I do is I like to list all the equipment that's possible to use in that job, because you never know, something might break down. You know it's going to break down eventually. So just make sure you got other equipment in there so you don't stop your production on the job. Also on the paving plan there, Jay had pointed this out. What I like to do is just have a separate document for a paving plan to use, and just turn in usually at the prior to the job, and then it gives the actual sequence of how you're paving it. So it's a little cleaner than putting it into this document. Material feed systems Jay talked about. Slope controls, all your joints, whether it's longitudinal joints, transverse joints or butt joints, taper joints, all that's addressed in your QCP. Start of paving, and then list of your asphalt materials that you're using on that job, grade source, where it comes from. Joint compaction, how you're going to compact your joints. Say Jay talked about that. Longitudinal transverse joints, compaction. And then we get in number 7, back to material sampling. The QCP for the job, the 803, it pretty well it follows along, or a good sister document is the ITM 583, which is our plant certification that we have at any mix that goes to a INDOT project is going to be a certified plant, so it'll have their own QC plan at the plant. So I always include all the plants that it could possibly feed that job. So that's why there's quite a few plants listed in here. Each one of these plants has their own QC plan. Mixture, addressing the paver temperature, or the temperature of the mat at the paver. So the QC technician, whether it's a laborer or operator, whoever, testing the equipment or testing the mix for temperature, how you're doing your density, just addressing the calibration strips, coring, how we're going to fill in core holes. That all needs to be addressed in your QCP. Response to test results, number 8, just, and it goes through, there's the 5 items in here, just mixture, mixed temperature, density. These are just things that you have to address in your QCP. Pavement smoothness, I just have in here that those are things that are addressed in the for polygraph. So again, we'll have to be putting IRI in all this. Documentation, main thing is 3 years. Documents are kept for 3 years in some location. And then all the rest of the document and this QCP is some extra stuff that we just like having involved in a plant. Seal codes, just keep on strolling, Jamie, please. The anti-segregation checklist. Some great pictures. Very interesting stuff. And then just using these forms that Jay had talked about. Then the last thing is the signature page, and we'll see how much longer this guy works for us. But just sign and given to INDOT PE, and then he'll countersign it and send it in to get approval, and you'll be ready to pave. And with that, I am finished. Jay, unless you got any questions, I'd be glad to take questions. Me or Jay? Everybody's ready for a break.
I think so.